In this video, I'm going to be showing you a trick on how you can use electronegativity, in calculation of oxidation number. Now, this is a sketchy chart of the periodic table. You see, we have hydrogen to fluorine. Now, we know hydrogen has an oxidation number. It has a +1 oxidation number. When oxygen is directly attached to a metal, you have a -1. It carries a -1. While when it's directly attached to a non-metal, it carries a +1. Now, oxygen has a -2 when it's an oxide. When it's a peroxide, it has a -1 oxidation number, and when it's a superoxide, it has a -0.5 oxidation number. For halogens, that is fluorine, chlorine, bromine, and iodine, they usually have a -1 oxidation number. Now, the group 1 element which are directly under hydrogen, that is, we have sodium, potassium, rubidium, cesium, and francium. Sorry, this is supposed to be R. Francium. They all carry a +1 oxidation number. Now, if you look at this element, you see that their electronegativity. We have hydrogen has electronegativity of 2.1, and then fluorine has electronegativity of 4.0, making fluorine the element with the highest electronegativity on the periodic table. Electronegativity, it increases up the group and increases towards the left, right? Now, one thing I want you to also note is that the electronegativity of elements at their ground state, let's say fluorine, sodium, like the way they are now at their ground state, their oxidation number, sorry, not electronegativity, the oxidation number of elements at their ground state, like the way they are now, is always equals to 0. So if you have sodium, for example, the electronegativity will be equals to 0. Now, what if you have an element, let's say a compound, let's say methane? Methane, since the overall charge is 0, it's equals to 0. The overall charge is 0, the oxidation number is equals to 0. But what if you have a compound like this, CO3-1? Now, the overall charge of this compound is -1. So the oxidation number, when you are calculating it, it will be equals to -1. When you solve for it, you then find out, you then get the oxidation number. So, electronegativity is the ability of an atom to pull electron towards itself. So we are looking at electronegativity and how it's related to oxidation, or how it's related to calculation of oxidation number. So take for instance, we have hydrogen on the periodic table. We have hydrogen. Let me change this my pen. We have hydrogen, we have boron, we have carbon, we have nitrogen, we have oxygen, and we have fluorine. Then we have chlorine, we have bromine, we have iodine, right? We have sulfur, we have phosphorus. Electronegativity increases up the group and also increases towards the left. So therefore, fluorine is the most electronegative element. Now, the electronegativity of oxygen is 2.1. The electronegativity of boron is 2.0. Electronegativity of carbon is 2.5. And that of nitrogen is 3.0. That of phosphorus is 2.1. Electronegativity of sulfur is 2.5. Electronegativity of oxygen is 3.5. And electronegativity of fluorine is 4.0. That of chlorine is 3.0. And that of boron is 2.8. And that of iodine is 2.5. So now, this is the electronegativity of these elements. If you look at it carefully, you see fluorine has 4.0, which means fluorine is the most electronegative element. Now, let's look at how this is related to calculation of oxidation number. Take for instance, we have oxygen difluoride, right? And we are to calculate the oxidation number of this particular compound. Now we know that fluorine has electronegativity of 4.0 and oxygen has electronegativity of 3.5, sorry. Now you see, between fluorine and oxygen, which has higher electronegativity? Fluorine, right? So fluorine will be partially negative while oxygen will be partially positive. Now what this means is that whatever element has the highest electronegativity in a particular compound, that element is the one that carries the negative charge, while the other element will carry a positive charge. Now in this case, and we know that fluorine usually is -1 when you are writing oxidation number. When you are writing oxidation number, fluorine, the halogen, fluorine, chlorine, bromine, and iodine, they always have a -1. They always have -1, right? We know oxygen to be carrying -2 on its own, and then it's carrying -1 as a peroxide, and it's carrying -0.5 as a superoxide, right? We know oxygen to carry +1 when it's attached to a non-metal, and it's carrying -1 when it's attached to a metal, right? So this is for oxygen, this is for halogens, and this is for hydrogen, right? Now pay close attention to this electronegativity values. Now because fluorine has the highest electronegativity, we say oxygen plus 2 fluorine is equals to 0, because the overall charge of this particular compound is 0, so it's equals to 0. Oxygen plus 2 fluorine minus 1 is equals to 0. Oxygen minus 2 is equals to 0. Oxygen is equals to +2. So you see, usually oxygen carries -2, but in this case, because oxygen is carrying the partial positive charge, the oxidation number is +2. Let's take another example. Let's say we have hydrogen chloride, right? Now we know that chlorine here has a 3.0 electronegativity value. That is EN value. I can just abbreviate it as EN value. 3.0 EN value, and then hydrogen has a 2.1 EN value. Therefore, chlorine is partially negative because it carries more electronegativity charge, and then hydrogen is partially positive. Therefore, we say hydrogen plus chlorine is equals to 0. The overall charge is 0. So hydrogen, just put hydrogen plus chlorine. Chlorine is -1, like we said earlier. -1 is equals to 0. Hydrogen is -1 is equals to 0. Hydrogen is equals to +1 when you carry it to the other side. Now, when written correctly, the element you are looking for its oxidation number is usually written at the left, while the one which you already get its oxidation number from the periodic table is written on the right. Now, let's take another example. Let's say we have sodium hydride, right? Now, how do we get the oxidation number of this particular compound? We know that hydrogen has an oxidation number of 2.1, while sodium has an oxidation number of less than 2, right? Therefore, hydrogen is partially positive, partially negative. It has more electronegativity, while sodium is partially positive. Now, when you want to write it, you say sodium plus H is equals to 0. The overall charge is 0. Now we know that hydrogen, since it's carrying a partial negative charge, you say sodium plus minus 1 is equals to 0. Sodium minus 1 is equals to 0. Sodium is equals to plus 1. Oxidation number of chromium and also the oxidation number of carbon. Now for the first one, to get the oxidation number of chromium, you know potassium, by the way, is in group 1, and you know group 1 elements have 1 valence electron, right? So potassium has a number from the periodic table you get as 1 to use in finding oxidation number. Now we know the oxidation number of the oxidation, we know the EM value of oxygen is 3.5. Now of potassium, we know is in group 1, is less than 2.1, right? Therefore, we know that in this particular example, oxygen, let's put down, oxygen is going to be electronegative than potassium and chromium, right? Because one, chromium is directly attached to oxygen, and oxygen is more electronegative. So we know that potassium carries a positive charge, plus 1. Oxygen carries a negative charge, minus 2. While chromium carries a charge with are yet to determine. Now, to do that, we say potassium 2K plus chromium plus 4O is equals to 0. Now we say 2, 1 plus chromium plus 4 minus 2 is equals to 0. So we say 2 times 1 is 2 plus chromium minus 8 is equals to 0. Now 2 plus 2 minus 8, we have chromium is equals to minus 6 is equals to 0. Chromium is equals to plus 6. Right? So this is going to be the oxidation number of chromium. What about the second example? Feel free to pause the video and try. What is the oxidation number of carbon in this second example? Now we know that oxygen has electronegativity value of 3.5, making it more electronegative. Carbon has a 2.5. Hydrogen has 2.1. And we know hydrogen has a higher electronegativity value compared to potassium, because electronegativity, they go up the group and down the left, right, towards fluorine. Now oxygen will be electronegative, carbon will be electropositive, partially electropositive, and hydrogen will be partially electropositive. So we say potassium plus hydrogen plus carbon plus 3 oxygen is equals to 0. Now we say potassium, which is what, plus 1, plus hydrogen is also 1, plus carbon is what we are looking for. Then plus 3O. Then plus 3O. Plus 3 oxygen, we have it to be minus 2. So it's going to be 3 minus 2. It's equals to 0. Now, next, we say 1 plus 1 is 2, plus carbon minus, this is going to be minus 2, 3 times 2 is 6, minus 6 is equals to 0. So we have plus 2 minus 6, carbon is going to be equals to minus 4 is equals to 0. Carbon is equals to, or you carry this minus 4 to the other side, it becomes plus 4. Right?